We're going to start by reviewing order of operations. And there's an acronym that many people like to use to help remember those order of operations. That would be PEMDAS, which stands for parentheses, exponents, multiply, divide, add, and subtract. Now, parentheses actually stands for any grouping symbol. It could be brackets. Fraction bars are also grouping symbols. Exponents also refers to things like square roots or cube roots. And the multiply divide steps are done at the same time. That's why I wrote them in the same line. We do that from left to right. And the same is true with addition and subtraction. We can do that at the same time from left to right. In example 1a, I only have addition, so I can actually work in any order I want. I usually like to start by adding all the positive numbers. 3 and 10 is 13. Then I add the negative numbers. -7 and -15 is -22. Notice to add two negative numbers, you just add their absolute values, you just add the numbers, and the answer is negative. Finally, to finish this problem, 13 plus -22 is -9. If you want to add numbers with different signs, you actually subtract them. 22 minus 13 is 9, and the answer takes the sign of the number with the larger absolute value. 22 is bigger than 13, and 22 is negative, so the answer is negative. Some people find it helpful to think about working with positive and negative numbers as similar to thinking about problems with money. For example, we could say that the $13 is money that we earned, that we were given, and we spent the $22, and so it would make sense that in the end we are in debt, we are at a loss of $9. Now, every single subtraction problem can also be thought of as an addition problem. Subtraction is actually defined as adding the opposite. So 12 minus 19 is the same as 12 plus -19. Now we can use the rules that we've already learned. We've got opposite signs, so we subtract. 19 minus 12 is 7. Because 19 is bigger than 12, the answer is negative. It takes the sign of the larger magnitude number, and the answer is -7. So notice, subtracting a positive number is the same thing as adding a negative number. Using that same reasoning, if you want to subtract a negative number, that is the same thing as adding a positive number. To change subtraction into addition, you have to change the sign of the second number as well. So 6 minus a -8 becomes 6 plus 8, and that's just 14. Another way of thinking about this last problem is you have two negatives. A negative turns into a positive. Some people like to think of those two negatives as kind of canceling each other out, or it's a double negative which turns into a positive. So putting all this together, if we want to simplify expressions with order of operations, we always look for parentheses first, then exponents. In example 2a, I don't see parentheses, I don't see exponents. First thing I see is multiplication. 4 times 7 is 28. Notice I have to do the multiplication before I can add. And then finally, 3 plus 28 is 31. In example B, I don't see any parentheses, I don't see any exponents. So next thing I have to do is I have to multiply and divide. I think about both of those steps at the same time, and I always work from left to right. So in the middle, there's my multiplication and division. I have to work from left to right. So that means in this case, I actually have to do the division first. 9 divided by 3 is 3. So I've got 16 plus 3 times 4 minus 7. Notice when I'm doing order of operation problems, I copy down the entire problem every time I do a step. And this is really important to help me keep track of things, especially when problems get more complicated. So now I have to multiply. 3 times 4 is 12. And I'll finish by doing the addition and the subtraction. 16 and 12 is 28, minus 7, and my final answer is 21. In example C, we have an exponent. PEMDAS says we have to do exponents before we multiply. Exponents mean repeated multiplication. 2 to the third actually means you're multiplying 3 2's together. 2 times 2 times 2 is 8. So I do the exponent before I multiply. I've got 3 times 8, and that gives me 24. Example D is similar. I work inside the parentheses first. Inside the parentheses, I have an exponent. I have to do that before I can subtract. 2 to the fourth is a product of 4 2's, and if I multiply 4 2's together, that should give me 16. I'm still working inside the parentheses. 16 minus 5 is 11, and finally 11 times 3 is 33. Example E, this one's a little bit more complicated, and earlier I mentioned that parentheses stands for all grouping symbols, and the fraction bar is another grouping symbol. What that means is you could actually imagine that there's extra parentheses around the top and the bottom, because we have to compute the numerator, then we compute the denominator, and then we finish by doing the division. So let's start with the numerator. I only see multiplication and division, so I go from left to right. 64 divided by 8 is 8, and 8 times 2 is 16. Then I'm going to work out the denominator inside the parentheses first. I've got a square root of 9. Well, 3 squared is 9. 2 squared is 4, so square root of 4 is 2. Inside the parentheses, 3 minus 2 is 1. Then I do exponents. 1 times 1 is 1. Finally, 1 plus 1 is 2. So my numerator is 16, my denominator is 2. I finished the problem by doing the division, and I'm left with an answer of 8. That was a very quick review of order of operations. Please let me know if you still have questions on this topic. You can ask those questions in class, or you're welcome to send me an email or stop by during office hours.